Okay,
Why
sir.
you were not present in the previous class, I think.
I was there, sir.
You was there, no? Okay, okay.
Yes, sir.
All right, so we were doing the chapter combustion and flame, right? So far in the chapter, what are the things we have learned? Yes, sir, Ibrahim and Vaika. We did learn about the process of combustion and we did define this process.
Yes, sir.
So let us start by revisiting that concept. So how do we define this process of combustion? What is it exactly?
Like when a substance burns, like in the presence of oxygen, basically air, and
Mm-hmm.
it undergoes a chemical reaction to produce heat and light.
Exactly. So that is combustion. Okay, no? Hope my screen is visible to everyone and I am also visible.
Yes, sir.
So we did learn that combustion is simply burning of a substance, right? More specifically, it is burning of a substance in the presence of oxygen, and in the process of its burning, it will be giving off heat, and in some cases, it gives light also, right? Also, it is said to be an exothermic process in which heat is released. Whenever you burn something, heat is released now. Yes, Aisha, Ibrahim, and Vaika, all fit on your cameras on in the class. So in the case of combustion, we learned that it is an exothermic process also. That is, heat is produced on combustion. Whenever you burn something, heat will be produced, right? Also, uh, there are some substances that will easily catch fire and there are some which will not catch fire easily, meaning that some will easily go through the process of combustion, will not. Some substances will not easily go through combustion. So on the basis of that, we have combustible and non-combustible substances, right? So combustible substances are generally the fuel which we have learned in the previous chapter also: coal, petroleum, natural gas, liquid hydrogen, most of the fuels which we have learned about them. So in the case of combustion, what happens? The carbon present in the fuel would be combining with the oxygen. The carbon present in the fuel would be combining with the oxygen and will form carbon dioxide and would also release water vapor. So therefore, the main products of combustion are carbon dioxide and water vapor. Got this now so far? So we define the combustion as a chemical process in which a substance would be, in which basically a substance would be burning in the oxygen or air to produce heat and light. Okay. All of you have written down this definition or not, by the way?
Yes, sir.
All of you have written down this definition, no? Okay. By the way, on the basis of whether the combustion is happening slow or whether it is happening fast, or whether it is the substance is undergoing complete combustion or incomplete combustion, we have the following classification of combustion. Classification of combustion. Give this topic and then draw the chart which I'm drawing here. So on the
Okay, sir.
basis of rate of combustion, we have two types of combustion. One that is rapid combustion. Another one is slow combustion. Then another basis is that whether the substance is completely burning or whether it is not completely burning. So on that basis, we have complete combustion and we have incomplete combustion. Okay. So talking about the rapid combustion. So in the case of rapid combustion, it would be the process in which a substance would be reacting with oxygen at a temperature above its ignition temperature. It would be reacting with it above its ignition temperature. Getting it? And it will release large amount of heat and light in a very short span of time. That is rapid combustion. Okay. So for example, burning of liquefied petroleum gas or kerosene or petrol, all of them are examples of rapid gas or rapid combustion, right? So whereby the substance would be burning and it would be quickly releasing lots of heat and light in a very short span of time. Okay, no? So that is the example of the rapid combustion. Furthermore, we have examples of slow combustion also. Like for example, respiration that is happening inside our body. That is also combustion, but rather a example of slow combustion. Getting this? Okay. Another thing is that in the case of complete combustion, so when a fuel will be completely burning, when it will have access to sufficient amount of air, when it meets the um, proper ignition temperature, when it gets the proper temperature required for catching fire, and when the air is dry, so in that case the fuel would be completely burning. In the case of incomplete combustion, if the fuel is not good enough, if it's a poor fuel uh, or lack of oxygen, getting it now, or moist environment, so in that case the fuel will not burn completely, so thereby it will go through incomplete combustion. In the case of complete combustion, it has to be good and efficient fuel. If it's a good fuel, if it gets a proper ignition temperature and the environment is dry, if the surrounding is dry, in that case it would be going through a complete combustion. In the case of rapid combustion, what did I told you? That when a substance would be chemically reacting with oxygen at a temperature above its ignition temperature with the evolution of high amount of heat and light, meaning that for example a substance requires, let's say, 200 degrees Celsius to burn, right? It's the minimum temperature required. That is the ignition temperature of a fuel, for example. But what if it were to be exposed to 250 degrees Celsius? So it will burn more rapid, isn't it, Vaiga, Aisha, and Ibrahim?
Yes, sir.
Yes. Right now. So say, for example, let's say you are burning wood. So wood will require a given amount of ignition temperature. But if what if you were to give it more than the required ignition temperature, it will burn more rapidly now. Getting it, guys? So when rapid combustion will be happening, it will happen when the ignition temperature is above than the required. So when a substance gets ignition temperature more than required, good availability of oxygen, then it is a highly efficient fuel, or in other ways we can say that it has high calorific value. High calorific value. For example, fuels like liquefied petroleum gas or kerosene or petrol, their calorific value is usually high. Their calorific value is usually high. Right now? Then we have examples of slow combustion. Slow combustion would be particularly that kind of combustion in which light will not be produced. No light will be produced. And the temperature of the substance would almost remain unchanged right now. Unchanged, I mean to say that. Getting it? So for example, respiration, it's an example of respiration, or for example, digestion of food. All those are the examples of slow combustion. Or for example, you have a yellow phosphorus at room. You have a yellow phosphorus So that will also be going through a slow combustion. Okay, now it will be going through combustion and its temperature will not vary that much. It will basically remain the same throughout the process of burning. So in the case of slow combustion, the following things are observed. No light is given off when the substance would be burning. No light would be given off. Okay. Furthermore, the substance would go under slow combustion without giving off any flame, without catching fire. So without catching fire, substance would go under slow combustion. We have the examples of digestion of food or respiration. Digestion of food, or we have the example of respiration. So you guys understanding what I'm trying to say? Then we did learn about complete combustion. In the case of complete combustion, the substance would be completely burning. It would be completely burning, right? And when it would be burning completely, so thereby it would be giving high amount of heat and light, no? Isn't it, Aisha, Vaiga, and Ibrahim? So
Yes,
high
sir.
amount of heat and light will be given off in the case of complete combustion. Okay, now also carbon dioxide, a good amount of carbon dioxide will also be formed in this, right? Because the complete oxidation of carbon present in the fuel would be taking place. In the case of incomplete combustion, for example, if you were to burn coal in absence of air or in very limited quantity of air, so thereby instead of carbon dioxide, a poisonous gas, a toxic gas called as carbon monoxide is released. So in complete combustion, we'll be giving carbon monoxide gas. Got this now? So the incomplete combustion takes place in the in insufficient quantity of oxygen, or if the fuel is very poor, or if the environment is moist. So thereby, the carbon in the fuel would be burning in a limited quantity of air, and hence will give carbon monoxide. So hope you guys are understanding what I'm trying to say. Then we did learn about combustible and non-combustible substances. So in this, we did learn that combustible substances are the one that would be burning very fast. They would be burning readily and will give good amount of heat and light. We have the examples of liquefied petroleum gas. We have example of paraffin wax, the wax that is used in the candle, or kerosene, paper, or wood, or coal. These are combustible substances. Then we have the example of like water or glass, sand, cement, rocks. These are non-combustible substances. Okay, no? Then we were learning about the necessary conditions required for combustion to take place. What are the necessary conditions required for combustion to take place? Via some activity also we did learn that. So combustible substances, first of all, there has to be a supporter of combustion. So we know that oxygen is a supporter of combustion. Getting it? Without oxygen, combustion will not be fast. It will not happen. Getting it? So we know that oxygen is necessary for combustion, and in most of the cases, oxygen is available from air when a fuel would be burning. Another condition required for combustion was ignition temperature, the minimum temperature at which a substance would be catching fire and will start to burn. That is known as its ignition temperature, right? So those are the main conditions required for it. Okay, now. Furthermore, types of combustion, few of the things moments ago we have discussed about this. It is very much related to what we're going to learn right now. In fact, we did learned about types of combustion in the previous classes also. Okay, so as I gave you this chart over here, in the case of the rapid combustion, we did learned about that. Okay, no. So here heat and light would be released in a very short span of time. A spontaneous combustion is basically the slow combustion that would be happening slowly, and the substance would be catching fire on its own. External source of heat is not provided. For example, forest fire, you haven't lit a matchstick there. so it caught fire on its own. For example, you have the example of like yellow phosphorus. So yellow phosphorus would catch fire on its own. Okay, now, but the flame will not be visible. The flame, it does not gives off any flame, or it does not burns with a flame. Although it will be going through combustion, but the flames are not given off when a yellow phosphorus burns. Then we had the example of explosive combustion also, where we did learn that in a short span of time, huge amount of heat, light, and sound will be produced in the case of a explosive combustion. So in explosive combustion also, uh, I did told you why sound is produced. So you guys explain this to me. Yes, Vaiga, explain this. Why sound is produced when a firecracker is burnt? Yes.
Like due to the large amount of gas formed during the reaction, and when that
Large
gas
amount of
tries to escape.
not escape, expand.
That's fine, yeah.
Okay, na? So what happens as a large amount of heat is given off? So the gas that would be coming out from the firecracker, due to the high amount of heat, it would expand at a rapid speed. It will uh, expand, so kind of creates a sonic boom, or kind of gives a huge amount of sound. That is the reason. And here in this chart, you can basically see the how three types of combustion has been classified: rapid combustion, spontaneous combustion, and explosive combustion. Along with their examples also, it has been given here. So rapid combustion is very fast. Spontaneous combustion takes place on its own. And explosion, here combustion causes large release of large amount of heat, light, and sound. And the following examples are given over here. So this much we have learned. Furthermore, we are going to learn about other concepts like what is a fuel and what are the ideal fuels, what are these things. Okay, so previously in the previous class, we have learned about fuels. So fuels are basically the combustible substances which on burning would produce a large amount of heat and light. That is what a fuel is. Yes, Ibrahim? So we learned the following things: a combustible substance which on burning produces a large amount of heat and light. Also, we know that fuel has been classified into three types. What are the three types of fuels which we have based on their state? Yes, Aisha, what are the three types of fuels which we have based on their state?
Liquid fuel, solid fuel, and
Very good. Liquid fuel, solid fuel, and
gases.
gaseous fuel. Good. Okay, you guys quickly give the examples of each one of them. You give the examples of liquid fuel.
Petroleum.
Petroleum, good.
Diesel,
Not petroleum, it would be appropriate to say petrol. Okay, na?
diesel,
Diesel, good.
kerosene,
Solid fuel coal.
Very good. Petrol, diesel, example of kerosene. Okay, na? Petrol, diesel, kerosene, and for solid, as you gave example of coal and
charcoal,
charcoal. Very good.
coke.
Coke. How about wood?
Yes, sir. Would
Right,
also.
na? Wood also. And we have example of animal dung cakes also. Animal dung cakes. Okay, Aisha, you also give some examples of gaseous fuels.
Hydrogen gas.
Hydrogen gas, very good.
LPG.
LPG, very good. We can take that one also.
Coal gas.
Coal gas, very good. And
CNG.
CNG, good.
All natural gases.
CNG is basically the compressed natural gas. In natural gas, you can count example of biogas also. Biogas is also kind of natural gas, although it is not extracted from the earth, but it is made by a natural process. So in a literal sense, we can call it natural gas. Okay, now so biogas or sometimes also called as gobar gas. Okay, now. So these are some of the types of fuels based on the state we have, right? So we have the examples of liquid fuels. So liquid fuels would be basically the fuels which would be volatile in nature, meaning that when they are burned, they would be producing vapors. Right now, liquid fuels, when they are burned, they would be producing vapors now. So all the liquid fuels would be burning with a flame. Right now, all the liquid fuels would be burning with flame. So liquid fuels, all of them, what we observed that they are volatile in nature. You guys understand about this term volatile or not? You guys understand now what is volatile? See, volatile would be something that would easily evaporate. That will easily evaporate at the normal room temperature also. For example, if you were to have 1 liter of petrol or diesel or kerosene, and if you were to left it in the open, so slowly, although slowly, it will be converting into the vapor state. After a week or after a month, you will observe that the amount will be decreasing. So that's why they have to be kept in closed containers, kept in closed bottles. So liquid fuels are volatile in nature, that they will be converting into the vapor states. Once they get some heat, they will be converting into the vapor state. Okay, no? And these are the most commonly used liquid fuels. Then talking about the solid fuels. So solid fuels they are the combustible substances which would remain at solid state at the room temperature. Getting it what I'm trying to say? They have to remain in the solid state at the room temperature. Okay, no? So that is the thing about them. They remain solid at the room temperature. And solid fuels would be mainly containing carbon in them. Okay, now solid fuels like coal, charcoal, coke, wood, animal dung, cakes, they would be mainly containing carbon in the form of different kind of hydrocarbons present in them. Okay, no? And particularly in rural areas, rural areas, they would be used as domestic fuels, apart from being used in industries also. Then we did learn about gaseous fuels. So gaseous fuels are the kind of, basically they are combustible gases, or they are mixture of combustible gases that are the gaseous fuels which we have. And these were some of the common gaseous fuels which we have. Okay, no? So this is the classification of fuel on the basis of their state. Next, we're going to learn about what is the characteristics of a good fuel. What is an ideal fuel? So an ideal fuel would be the one that would be fairly cheap and would be easily available to everyone. The first thing is that it should be, you guys also mentioned some of the points about ideal fuel. What would be a very good fuel?
It should be affordable by everyone.
Good. The first point already listed. Yes, Aisha? Weiger?
It should be accessible to everyone.
Good.
It should be like safe to transport it.
Very good. Safe to transport.
Burn easily in air.
And not that
Oh.
much pollution.
We can say that it should be burning at a moderate rate. Moderate rate. Okay, now? We should.
Non-polluting in nature.
Very good. At a moderate rate. Moderate rate means that neither it should be burning too slow, neither it should burn too fast.
Yes, sir.
Burn at a medium level. Good. And should not release No polluting gases should be released from it. Okay. Also, it should not leave behind any residue after burning. No, should not leave behind any residue. For example, ash. Right now, getting it. Also, we will like an ideal fuel should have a high calorific value. Right now, meaning that with just a small quantity of fuel, it should be giving high amount of heat. Right now, so it should produce large amount of heat per unit mass, meaning that you have 1 kilogram of fuel A, 1 kilogram of fuel B. So we will look at which one of them is producing more heat by just burning 1 kilogram of it. And it should be safe and convenient for storage and from transportation point of view also. Okay, what if it were to ignite at the room temperature? Will it be okay? What if it catches fire at the room temperature? Yes, Aisha? Yes, Vaika? What if it were to catch fire at the room temperature? It will not be okay, no? So it should have a ignition temperature more than the room temperature. Getting it now? We can say that should not burn at room temperature. At room temperature. Otherwise, in another way, we can say that it should have higher ignition temperature as compared to the room temperature. As compared to room temperature. Hope you guys are understanding this. Okay. Then fuels are used for different purposes, right? Talking about the uses of fuels, fuels would be used for different purposes. Like fuels would be used for cooking and for heating purposes. For transportation purpose, it would be used. Most common fuel would used for the purpose of cooking would be the kerosene or coal, or coal and charcoal would be particularly coal, charcoal, or cattle dung cakes would be particularly used in rural areas, while kerosene or liquefied petroleum gas would be used in urban areas particularly. Okay, no? For transportation purpose also fuels are used. Fuels such as petrol, diesel, or CNG are used for running cars, for running scooters, buses, trucks, and even trains also, right? Furthermore, the there are certain kind of fuels that would be used as a aviation fuel, meaning that they would be used in aeroplanes only. Fuels are used for generating electricity also, like coal is used in the thermal power plants to generate electricity. Basically, the coal would be used for generating electricity in a commercial scale, in which what happens, mm, uh, the coal would be burned to produce steam. It would be used, it would be burned to boil up the water, and the steam that would be generated, it would be used to turn the turbines. And in the process of turning the turbine, electricity is produced, and that electricity is um, stored and sent to our homes, sent for domestic purposes, right? Furthermore, we know that in industry also fuels are used. Fuels such as coal or natural gas or diesel or some other fuels are used in the industries for various purposes. It is used there. Getting it now? Another use of fuel is for launching vehicles in the space, for launching space vehicles also. Like space vehicles are launched with the help of rockets now, and rockets would be using a special fuels called as propellants. What do we call them as?
Rocket
Propellants.
fuel.
Yeah, rocket fuel, or they're basically propellants, right? So propellants are different from different other kind of fuels. Right now, they are different in a sense that they would be containing a fuel, and they would contain some other special things in it also called as oxidizer. Although not important and relevant, but know that propellants are not the usual fuel that we use at our home. So it is kind of different from LPG or kerosene. Getting it now? Its calorific value will be very, very high. So also it is not safe like rocket fuel, you can't use it for other domestic purposes. It will be dangerous. Okay. Okay, I should read the given paragraph.
Calorific value and efficiency of a fuel. The amount of heat energy produced on the complete combustion of 1 kg of a fuel is called its calorific value. The calorific value of a fuel is expressed in a unit called kilojoule per kg.
Good. And you guys look at the given image over here, given image, and tell me which one has got the lowest and the highest calorific value in this. Yes, we can clearly see that hydrogen gas has the highest calorific value. 1 point, how much? 1.5 lakh kilojoule per kilogram. Okay, while cow dung cakes have the lowest calorific value. So you guys tell me which one of them would be releasing lots of harmful, lots of polluting substances. Which one would be most polluting? Yes, which one of these fuels is most polluting? The one which will be having lowest calorific value. So that one is much polluting. Getting it? So the cow dung cakes would be much polluting. Wood is also very much polluting, and coal. These are the fuels which are having low calorific value and are much polluting in nature. The important thing which we have learned that efficiency of a fuel would be determined by its calorific value. Higher the calorific value, more efficient the fuel will be. So hydrogen gas will be most efficient fuel, meaning that it will go under complete combustion. It will completely burn without leaving any residue. It will also not release any toxic or harmful gases. Okay. Now, how do you find the calorific value? Suppose if I were to give you a certain amount of fuel, let us say that if I were to give you 5 kilogram of a fuel, let us say I were to give you 5 kilogram of coal, okay, and I say you that this much of heat is given off upon burning it. So how you would be calculating its calorific value? Let us learn that with an example. So we have one example given over here. In an experiment, 4.5 kilogram of a fuel was completely burnt. 4.5 kilogram of a fuel was completely burnt. And the heat produced was measured to be 1,80,000 kilojoule. By the way, kilojoule is a unit of heat. Heat is measured in joules or kilojoule. Okay, now you can measure heat like in the temperature, you measure it in Celsius or degree Celsius, right? Now, degree Celsius or degree Fahrenheit or in Kelvin, that's a different thing. Heat will be measured in kilojoule also or in joule also. So you have to find the calorific value of the fuel. So it is very simple how we are going to do that. The formula of the calorific value is, it is amount of heat released divided by amount of fuel burnt completely. Amount of fuel burnt. So Vaiga, how much of fuel, how much of heat has been given here? 1,80,000, right?
Yes, sir.
And how much of fuel was burnt? 4.5 kilogram. Also pay very close attention to this thing that the unit of calorific value is in kilojoule per kilogram. So make sure that the given value in the question is in kilogram. If it is in gram or in other unit, you have to convert it into kilogram. Okay. And the heat is in kilojoule. So upon dividing, you'd be finding that it gives around 40,000 kilojoule. That is the calorific value. And you have calculated it on a unit basis now. So the answer is 40,000 kilojoule per kilogram, meaning that upon burning 1 kilogram of that fuel, 40,000 kilojoule of heat is given off. If all of you have understood this, I'm going to give you one question to solve. Please let me know if this is clear to everyone or not.
Yes, sir.
Others? What about others?
Yes, sir.
Yes, sir.
So question says that you have to answer 5.8 kilogram of a fuel is burnt. Okay, then you have to answer that 290,000 kilojoule of heat was given off, is given out. Calculate the calorific value of that fuel. Not that difficult. It's easy. All of you would be answering in the chat box. Okay. Yes, Aisha, you have answered.
Sir, I did answer it.
Yeah. Yeah. So that is correct. Okay, no? Thereby the given amount of, okay, Ibrahim, you are left to answer it. Just let me check it. Yes, very good, guys. Okay, now. Also, Vaika and Ibrahim, make sure that you write down the unit also. Aisha, you have written down, very good. Okay, now.
Yes.
So that would be 50,000 kilojoule per kilogram. So hope that topic is clear to everyone. Okay, now. Okay. The next thing we are going to learn about is that how we can control the fire. Okay, now we have learned what are the factors responsible for a combustion, for fire to take place. What are the necessary things required? First of all, you guys list down the necessary things required for fire to take place. Then we'll be learning about that, how a fire is turned off. Just quickly. What are the necessary things for combustion to take place?
Oxygen.
Temperature,
Ignition temperature. And
Combustible substance.
that is a fuel. Very good. So these are the three necessary conditions required for combustion to take place. Okay. So these are conditions necessary. So fire can be controlled by removing any or more of those conditions. Right now, fire can be used to fire can be controlled or turned off by removing either fuel, either a supply of oxygen, or either lowering the temperature of beyond the ignition temperature. Right now, if you were to lower the temperature, or either either you can cut off one of these three, or either you can cut two or more than two of these three. So we have the most common thing, like we have the fire extinguisher. Using a fire extinguisher, basically fire is turned off. Getting it now? Basically using a fire extinguisher, it is done. Apart from that, there are several other methods via which we would be able to turn off the fire. But before you turn off the fire, you first thing that is important is you need to identify the cause of the fire. What has been the cause of the fire? For example, uh, if there's a fire due to electricity, if there's an electrical short circuit somewhere, and that has been the cause of fire, we know that how electrical short circuits happen. You guys know about this now? How electrical short circuits happen? Yes. Meaning that what happens now when a live wire and a neutral wire which will touch directly, then electricity will pass through only one wire, and that will lead to release of lots of heat also, and that will lead to fire. Getting it? What happens, like if the wiring in the house has not been done properly, if the wiring is faulty, Aisha, Brahim and Vaiga, if the wiring in the house has not been done properly, so what can happen sometimes now, or if the insulation, the rubber insulation of over the wire, sometimes it is cut off, it is cut right now. So in that case, what might happen, a live wire and a neutral wire might come in contact. Okay, so in that case, what will happen, like sometimes they comes in contact now. One moment. Okay, they have came in contact like this.
Sir,
Yes.
can I use restroom?
Okay. So what might happen now here, the wires connection of the wire might not have been proper, the wiring might not have been done properly. So in this, what will happen, the live wires and the neutral wires, say that this is the live wire and this is the neutral wire. So current might start to flow in just one of them. Then earlier current was flowing in the different wires, but now both the currents will now flow in the same wire. So thereby, when the live and neutral wire comes in contact with each other, the electricity will now flow in just one wire. So thereby, the circuit is said to be broken, or it is not broken. I would say it was said to be cut to short. It has been shorted. Getting what I'm trying to say? So that will lead to generation of sparks also. So here, sparks will be produced when live and current wire comes in contact. Sparks are produced, and that spark could be the cause of fire. That spark could be the cause of fire. So hope you guys are understanding this concept of electrical short circuit. When a live wire and a neutral wire comes in contact with each other, so they, by the way, neutral wire, you guys understand now, it's the wire that is connected to the earth. You use the neutral wire for the earthing. Okay. This neutral wire, using this, earthing is done. Okay, Ibrahim, Aisha, and Vaika. So when these two wires will come, thereby it will lead to release of sparks, and that spark will lead to fire. So in this case, will it be appropriate to use the water to turn off the fire? Think of it. Of course, no. So we will not be using water in order to extinguish the fire in that case. So what we can do, we'd be using some other methods we should be learning. So talking about extinguishing the fire, generally water is used as the most common extinguisher for the fire. It's the most common fire extinguisher, and the water can be only used when the burning material is like it is wood, it's a cloth, or it's paper, something like that. Something like you have wood on fire, or you have paper on fire, or you have coal on fire. So on that cases, water can be used. But water cannot be used if electrical equipments are on fire, because we know that water conducts electricity and it can harm those who are trying to put out the fire. If this house is on fire because some electrical equipments have caught fire, or there's been a short circuit, so thereby it cannot be used. Okay, furthermore, you guys tell me, like if the cause of fire has been oil or petrol, So will water work there? Like for example, the cause of fire in this house has been oil, like petrol, for example. No. Why water will not be efficient in putting off that fire?
Water will signal.
Complete your answer, Ibrahim. Aisha, why we cannot use water when the cause of fire is petrol or kerosene or a liquid fuel like this? Okay, you guys tell me which one is lighter or which one is heavier out of water and oil. Which one is lighter? The
Water.
density.
So
Water is lighter. No. Oil is lighter. No. That's why oil floats above the water. No.
yes, sir.
So what will happen if you were to pour water over there? No, it will not be of any use. Water will go down the oil and oil will float above the water. Oil will float above the water. Hence, you will not be able to turn the fire off. So thereby, water cannot be used to put out the oil and petrol fires because oil floats on the water and the oil will continue to burn. Getting it? No? It will continue to burn. So then the question is that how to turn off the electrical short circuit fires? What should be done in that case? Think of this, you guys. What should be done?
So
Like
what is the
whenever
question?
my question is that like whenever you notice a electrical fire, the fire caused due to electricity. So what is the first thing you need to do?
Shut off the electrical.
Yes. Yeah, switch off the electrical appliance. Yeah, many times it can be a dangerous thing to do, but if it is safe to do, so you can unplug the appliance or turn off the main switch from the electrical panel, right? Or you can try something like if you have lots of baking soda, you can use that too also. That also helps in turning a fire. Or if you have like sand can be used. Getting it? Or
Yes,
the
sir.
best thing would be if you have a carbon dioxide fire extinguisher like the one that you see in this image. This carbon dioxide fire extinguisher, if you have this one, that would be the best thing to do. Okay, na? So this is
Okay,
the
sir.
best option which we have. Also, avoid throwing water on that. Never throw the water on fire caused due to electrical short circuits. Got this now? So fire can be controlled by removing one or more requirements essential for producing the fire. What is commonly used for controlling those fires that is caused by substances other than oils and electrical equipments? Because if you were to use water, it can worsen the situation. Okay, no? Okay. Talking about the use of carbon dioxide over here. By the way, there are different type of fire extinguishers, not just the carbon dioxide. Carbon dioxide is the most common fire extinguisher we have at different places, at offices, at schools, at homes. But there are different kind of like the water can also be put into this like, fire extinguisher and can be used as a fire extinguisher. A foam or powder, it is also used. So carbon dioxide would be the best fire extinguisher that you can use to put out the fire that is caused by oil or petrol or electrical equipments right now. Now let us understand how carbon dioxide works as a fire extinguisher. We know that like oxygen is a supporter of gas. I mean to say it's a supporter of combustion, while carbon dioxide has just the opposite property. It does not support combustion. So say for in an area there's a fire. So this, let us say this is some wood that is on fire, and you want to turn this fire off. So you can simply sprinkle water, but let us say you are using the carbon dioxide fire extinguisher. So how it is going to work? Okay, now I should first of all read the given paragraph, this one.
In a carbon dioxide extinguisher, the carbon dioxide is kept in pressurized liquid form in the cylinder. When the container is opened, the carbon dioxide expands to form a gas in the atmosphere.
Good. So all these cylinders that you see over here, the carbon dioxide gas here, it is stored in the liquid form. Okay, so with great amount of pressure, the carbon dioxide gas will be put into great pressure, and when gases are put into under high pressure, it converts into the liquid state. Right now, just like natural gas, just like you have liquefied petroleum gas, the petroleum gas is compressed and the temperature compressed, and then it converts into the liquid state. So same thing here also. Carbon dioxide in these cylinders have been stored in the liquid state. As soon as you turn on this nozzle, as the nozzle is turned open, so thereby why this pipe, lots of carbon dioxide gas will be released. Okay, now while this fuel is burning, while this wood is on fire, it is having a supply of oxygen gas now. Getting it, guys? It is burning in the presence of oxygen. Now, as soon as the carbon dioxide gas is released, what will happen? Carbon dioxide gas will form a blanket over this. It will form a blanket over this. Okay, a layer of carbon dioxide gas will accumulate over this. Now, the property of carbon dioxide gas is that it is heavier than oxygen. It is heavier than oxygen. So if it is heavier than oxygen, it will displace the oxygen gas now. The oxygen gas will be displaced from here. Getting it, what I'm trying to say?
Yes, sir.
Yeah. So carbon dioxide gas being heavier than oxygen, it will displace the oxygen gas, thereby cutting off the contact of oxygen gas to the fire. Okay, now? So it is heavier than the oxygen. Okay, now? And it covers the fire and thereby cuts off the supply of oxygen and puts out the fire. So hope you guys have understood this. Okay, now?
Yes, sir.
Okay. Now there are another kind of carbon dioxide cylinders also, like the one that you see over here. In this one, the carbon dioxide has been stored under high pressure. It's pure carbon dioxide liquid of carbon dioxide. The modern fire extinguishers are of this type, in which the carbon dioxide is stored in the liquid state. But there are some other kind of fire extinguishers also. Okay, na? In some other kind of fire extinguishers, certain kind of chemicals like sodium bicarbonate, that is baking soda, or potassium bicarbonate would be used to produce the carbon dioxide. Okay, now one of you please read the given paragraph from where I will be highlighting. Okay, Vaika, you do one thing, you read from here. Read from here.
Okay, sir. Okay, sir. How do we get the supply of carbon dioxide? It can be stored at high pressure as a liquid in cylinders. In what form is LPG stored in cylinders? When released from the cylinder, CO2 expands enormously in volume and cools down. So it only forms a blanket around the fire. It also brings down the temperature of the fuel. That is why it is an excellent fire extinguisher. Another way to get CO2 is to release a lot of dry powder of chemicals like sodium bicarbonate, baking soda as potassium bicarbonate near the fire. These chemicals give off CO2.
These chemicals will be giving off CO2. So, Aisha, what are the chemicals used in this? Read the name of chemicals.
Sodium bicarbonate, baking soda, or potassium bicarbonate.
Potassium bicarbonate. So sodium bicarbonate is basically baking soda. Keep that in mind. Okay, na? So that is basically baking soda. So let us understand what happens over here. So in the last paragraph, it says that another way to get carbon dioxide is to release a lot of dry powder of chemicals like sodium bicarbonate or potassium bicarbonate near the fire. How does that work? See, like some kind of fire extinguishers would contain powders of sodium bicarbonate. Okay, na? Getting it? Some of them would contain powders of sodium bicarbonate, that is baking soda. Or for example, let us say that if there's a fire, you see fire somewhere and you happen to have baking soda with you. So what you can do, you can simply sprinkle the baking soda above the fire. What happens? You guys think of this question, that what will happen when you put the baking soda on the fire? What would be happening? Like it would be extinguishing the fire. That happens. Okay, that happens. But what exactly is happening while you're doing so? Yes. What
This
basically
chemical
happens? Mhm.
of CO2.
That would be giving off CO2 gas, right now. Very good. So when you pour it over that, CO2 gas would be given off. Okay. Furthermore, you guys yourself can make a fire extinguisher at home. You all would be having vinegar at your home in the kitchen, right? And baking soda would also be available in the kitchen, right, Vaika? So take some vinegar
Yes, sir.
and take some baking soda. Mix them.